One technology is quietly transforming healthcare, transportation, education, and almost every industry on Earth. That technology is machine learning. First, what exactly is machine learning? One of the earliest definitions came from researcher Arthur Samuel. He described machine learning as giving computers the ability to learn without being explicitly programmed. Instead of writing every rule by hand, we allow computers to learn patterns from data. And that simple idea changed everything. To understand how it works, imagine you're trying to predict the price of a house. You collect data. House size, house price, house size, house price. Again and again. Eventually, a pattern starts to appear. The bigger the house, the higher the price. A machine learning algorithm can learn that relationship and estimate the price of a new house it has never seen before. This is called supervised learning, the most widely used type of machine learning. The idea is simple. Give the algorithm examples, an input, and the correct answer. Then let it learn the relationship between them. But predicting house prices is only one type of problem. Sometimes the answer isn't a number. Sometimes the answer is a category. Imagine a doctor examining a tumor. The goal isn't to predict a price. The goal is to predict whether the tumor is benign or malignant, safe or dangerous. Now the algorithm must learn to place each example into a category. This type of problem is called classification. And together, regression and classification form the foundation of supervised learning. But real-world problems quickly become more complicated. A doctor might look at tumor size, patient age, cell shape, cell structure, and many other factors. Suddenly, there are too many variables to visualize, too many dimensions to draw on a graph. Yet machine learning algorithms can still discover patterns and relationships hidden inside that complexity. And that's where things become powerful. Because machine learning isn't about memorizing data. It's about finding useful relationships that humans might never notice. But building a machine learning system isn't as simple as choosing an algorithm. One of the biggest challenges is deciding what to do when things don't work. Should you collect more data? Try a different algorithm? Use more computing power? Change the features? The most effective machine learning engineers aren't just experts in algorithms. They know how to systematically improve a model instead of relying on guesswork. Because machine learning is evolving into an engineering discipline that can be measured, tested, and improved. As the field grows, areas like deep learning continue pushing the boundaries even further. But every breakthrough still rests on the same fundamental idea: learning from experience, finding patterns, and using those patterns to make better decisions. From predicting house prices, to helping doctors detect cancer, to powering self-driving cars. Machine learning is becoming a tool that can reshape entire industries. But this raises an important question. How does a machine actually learn these patterns from data? How does it discover the relationship between house size and house price? And how does it improve its predictions over time? That's exactly what we'll explore next with linear regression and gradient descent.